Three types of factorization. One by common term. Second by using identities. Third by factorizing quadratics. Okay, using the midterm breaking. Okay, I will teach you how you can easily identify and use them accordingly to any scenario you may encounter. Here I have generated this paper. Okay, you guys can generate it also. Here are the settings you all guys want. IGCSE 0580 factorization all years paper 24 and 62 questions it fetched. Okay, there might be more in 4024, but who does 4024 anyways? Not like I gave it. Okay, first is common term factorization. How do you do it? That is by checking common things between them. You can do this by checking in three phases: coefficients, variables, and the students. Coefficient and variables. Here we see by coefficients that the common thing is 7. They both come in 7 tables, so this is like so. Next is variables. If you see, they have y common. Y, because y squared is 1y. If we divide by y, so this is 1 and this is just 1y. So we can divide by 7y to get 2x minus y. 2x minus y. Okay, if you want, you can verify this by expanding this and seeing it is the same as the step above. So this is how you factorize. Let's do some more questions. Okay, then we can get to the next type of next type of common term thingy. Okay, where we need to make pairs and then do them. Here we have 2 common. Next we have x common. Okay, if we see carefully, 1 x here and a few x's over here. So this is x squared minus 9y squared. I won't go further. This is in the next factorization type. Okay, so just keep it there. Here we see 9 is common. Okay, just by practice. Okay, don't worry. And p is common. So this is 2x minus 3 and done. 9 times 3 is 27, 9 times 2 is 18. Px and p normal. Now we'll do just one more and then we move on. Okay, like here we need to factorize. Now we need to take 4 common before we can move on. And like so, like they can be as simple as this question alone. Okay, for like free marks. Next is with 4 terms. How do you do this? Well, you can do this by checking under which variable are you making pairs. Okay, we can make pairs on example if they have q or if they have a. So they can be two types of pairs, 1 minus q and negative a plus aq. This is one pair. Or if they have q or not, 1 minus a negative q plus aq. Okay, both are same. Both have the same thingy. But the only thing that differs from them is that how you group them. Okay, here we have by a, here we have by q. Okay, but they will give you same answer, remember. Okay, let's just work on this only. We have this. Now the first term is nothing common. The only thing common is 1, because 1 times anything is anything and anything times 1 is anything. So we know it is only 1. Okay, next, how do we know the outside variable of this? Okay, a clue you guys can give yourself is having the same bracket on the other side. Okay, this helps to give you a clue. Now, ask yourself, what do I have outside such that when I distribute it on the inside, I get the outside pair. That's right, negative a. Why? Because negative a times 1 is negative a, and negative a times negative q is equals to plus aq. Plus is minus, so that's why. Next is writing it into brackets. The first bracket is going to be the common term. The second bracket is going to be the outside terms adding. Okay, now obviously 1 plus negative a is equals to 1 minus a. So that's right. Here we have the same argument. 1 is common between the first term. So we have this common in here. Now ask yourself what we have. This is negative q, 1 minus a, 1 minus q. Now our answers are the same because multiplication is commutative, remember. So you guys can interchange the terms of your answer. Okay, moving on, another example. Here we can group upon x or upon y. I'll group upon x because that's easier. 1 plus x, and here 1 is common, and negative y, negative xy. Here I'll use the same. Have this and ask myself the question, what should be the outside, and the answer would be negative y, and I can just add the outsides and boom. Here I can group upon m, upon n, or upon t. I will group upon m. So nice, and m is the common between them. Okay, and here we have n common between them. So naturally we might have it like this, but some may be confused as the insides are not the same. But don't worry, they are. Why? Because addition is commutative as well. So don't worry. Okay, this is the same as t minus 1. We just flip it, we have t plus negative 1, which is t minus 1. So that's the reason behind why this is acceptable. Okay, next, moving on, we have these as well. We can group upon m, upon p, or upon k. Let's group upon k. 2m plus 3p minus 8km minus 12kp. 2m plus 3p, we have one common between them, 2m plus 3p, and here we will use the clue method, 2m plus 3p. Now we know k is common among them, but we don't have the signs or the coefficients same. So to get the signs to be the same, we do negative, so that negative this is this, negative this is this. Now the variable, the coefficient, this will be 4k. Why? Because this will be negative 8k, and this will be negative 12kp. And finally we just add it together, 9 minus 4k, 2m plus 3p, like so. So this is how you do these questions. And one more, and then we move on to the identities. Okay, ux minus 2u minus x plus 2, upon u or upon x? Correct, upon u, because I feel like it. Okay, let's change it up and do upon x instead. How's that? X is common here, so u minus 1, and we have u minus 1. We'll use a clue method. Here we have minus, but here we have plus. Okay, So we know we will have minus outside and 2 outside as well. So this is x minus 2 u minus 1, like so. Moving on to the identities now. Now there are 3 identities. Okay, the first two being the square of a sum and the square of a difference. Okay, the square of a sum is like as follows, is equals to a squared plus b squared plus 2ab. You might also remember it as 2ab plus b squared. Okay, these two are the same. Okay, remember. Okay, if one reads it in this fashion and another one reads it in this fashion, they both are the same. Okay, remember. And if we just make this a minus, then this is just minus version of that. So for compactness, I will just write this once only with plus or minus symbol. Okay, just remember, only this thing changes. Okay, next is the difference of two squares formula, which is a squared minus b squared. Okay, difference of two squares. So the oh my god, okay, sorry. So these are the identities. Okay, and one thing you guys can see is, if we discard this type, then we see they have squares between, they have squares at both ends. Okay, sorry, I wrote the plus minus in the wrong area. It is with the 2ab bit. Okay, we have squares on the outsides. So this is how you can identify. You need to use the identity like so. There are some examples which use this, but I will give you an example which uses this. Okay, 3 examples which uses these, and then we can move on to the examples in the worksheet. Okay, here we have 3 examples. On all of these, we can see this and this. These are perfect squares. So we know this will be the first perfect square, which is 2a, 3u, 11x. Then the sign between them is governed by the sign of the middle term. Okay, here we have plus, here we have minus, and here we have plus. So this is plus minus plus. This is not a pattern. This is just the coincidence of this question. I can have this question be different, but that would mean this will be minus also. Okay, then we have the second, the last term. Okay, so this is 49b squared, which is 7b, and then this whole term squared, 5m squared, 6y squared. Okay, it's not that I know the answer, it's that I know that this will be the answer by just seeing the patterns. Okay, by these two are like governed like this, and the sign between them is governed like this. So this is how you can easily identify the first two identities. Okay, first two. Okay, that's how you learn it in class. The first two identities. Just don't know the names of the identities. You know, difference, the square of a different square of a sum. Okay, next is the third identity, which the worksheet has quite a few examples. Okay, which I found. Okay, like here we have, first we use the common term identity, common term factorization method. Next is the third identity. How do you know this? Well, this is by seeing that it is two squares with a minus between them. A difference of two squares. That's how we get the name. So the first square and the second square with a minus, and then the first square plus the second square. Okay, now your teacher or yourself can just write plus first and minus first. I just like to write minus first. There's no issue with writing plus first. Okay, don't worry, it's self preference. Okay, next we omit that, we divide the terms 5 minus x because that's how you solve the question, and like so. Another thing is, like here we left this because we do not know how to factorize it further, so we go further like we know, and x plus 3y is nice. Here if we go down we may find another unfinished question, like so. Here we first factorize out, we first remove 3 since that's common, and x, 3x which is common, x minus 4. Okay, this one slipped through the cracks being simple, but yes, this is how you do it. Okay, we will come to this later. Okay, just doing the numerator because that's simple. The denominator here is u minus 1, u plus 1. Now we have factorized the numerator as well, x minus 2, u minus 1. We remove these, so we get x plus 2, u plus 1, simplified. Yay. Okay, now let's do the third type, which is the most difficult type of all, factorizing a quadratic. Okay, how do you do this? Do we need to use plus, minus, midterm breaking, all those shenanigans? I will teach you every case and how you can identify them with great ease. Okay, so you might have heard how to do midterm breaking. You get AC, which is in this example negative 24, and then you may write the factors of negative 24, which are negative 1, 24, 24, negative 2, 12, negative 3, 8, negative 4, 6, and 6, and so on, so on, so on. Okay, you just have the first row negative, then if we can't do that, we'll just have the second row negative. Okay, so these are the terms of 24. Okay, how did I make this table? How do I know how I do this? Well, I make this, I make the pairs by the second rule, that they must multiply to the negative 24. Okay, so this is how you should make your pairs. They must multiply to the upper thingy. Some people just write it like so and then get confused as to how do we make pairs. When I was teaching, they made pairs like this. No, this is not a pair. We need pairs which multiply to the above mentioned number, which is negative 24 is in our example. Okay, next you want to find if they add to the middle term. Okay, now here this first case is this, the left side being negative, then for the next case we may have the other side be negative. Okay, if we need to, if we add this is 23, this is 10, this is 5, and this is 2. If we see, this is similar. If we just multiply, we just have this row negative instead, this is negative 5, which is our pair run. Okay, so this is how you can factorize easily. Okay, there's no magic about which row is minus, which row is plus. It's just about how you do it. Okay, the rows being minus or plus, I will tell you later after solving this. Okay, now we have negative 5 here. We have 3 and 8. So the midterm break negative 5 into 3 and negative 8. So this is 2x squared plus 3x minus 8x minus 12, and the common is x. 2x plus 3, 2x plus 3, common between them is a negative, common between them is a 4, so this is x minus 4, 2x plus 3, like so. This is how we do it. Now how do we know which rows are negative and which rows are positive, if we should plus the terms or minus the terms? How do we do all that jazz? Okay, plussing and minusing the terms, that is we don't worry about that, because remember, if we plus a negative number, that's just doing this. Okay, so there's no minus this term, minus that term, no, it is this, we are adding a negative term. Okay, there's no subtraction. Subtraction was never invented, it is negative addition. Next is the rows, if they need to be all negative, all positive, or some, or one half being negative. Okay, that is upon this and these two. Okay, if okay, let's keep a simple table. Okay, this will be for the B and this will be for the C. Okay, so let's go. If we have 5, 12, positive 5, positive 12, then this will be this case. Okay, both rows will be positive. Okay, both rows will be positive. If C is negative instead, okay, and this is positive, that means that one of the rows will be negative. One of the rows will be negative, and you just have to find if we have to have to do this or do this. So next is, if both are negative, then how do we know? No. If this is negative and this is positive, then this will be the case of both being negative. No, both being both being negative. Both being negative. And if it's this case, and it will be one being negative. Okay, that's how we do it. If C is negative, then both, and then one is negative. If C is positive, then either both are positive or both are negative. Okay, so this is how you can read this table, both positive or both negative. Okay, let's make it simple, let's re-explain it. Okay, this table is for whether both rows, when you factorize, when you find the factors of the AC term, okay, multiplying the first and the last coefficients, okay, which row should be negative, okay, in the which row pair should be negative and which row pair should be positive. Okay, 1 2 3 4 1 2 3 4 6 3 8. Okay, if we have both positive, okay, if we have both positive, okay, both terms positive, then which rows do we add? Well, we have both rows positive then. Okay, so here we know we will need to find two things which, when we add it, needs to be 5. Now this is an impossible case, but going on, if this term, okay, if in here this is negative, if this last term is negative, so obviously this multiplication will be negative, and for multiplication to be negative, only one row needs to be negative, so it would be like so. Okay, it does not matter if this is plus or minus, only one row will be negative. Okay, it might be this row or it might be this row. Okay, this is just by seeing the cases. Okay, if 3 negative 8 works, or 8 or or 8 minus 3 works. Okay, for our case. Okay, next, if both if this is no if C is positive and this is negative, then this will call for both rows being negative. Okay, got it? Because negative negative is positive, and if we add two negatives, I will give a negative, obviously. So that's how we do it. And this is also a impossible case for the question we have chosen right now. But when you go further down and see this case actually in action, then it will be then it will make sense. Okay, don't worry. Final case, if both are negative, what do we do? Well, you know, one row will be negative, and we want the addition with a negative number to give us a negative. Okay, as seen here. Okay, now this is also a impossible case for the question. No, this is the question. Okay, so like we did here, negative 3 plus 8 is 5, but if we just change the rows, then we see 3 minus 8 is negative 5. Okay, and this works out for us, which allowed us to factorize nicely. Okay, so this is just by practice. Okay, let's just see more examples of factorization so that we can get the hang of it. Now 6 times negative 20 is equals to negative 120. Okay, what are the factors of negative 120? 1 and 120 itself. Obviously, this can be divided by 2. So this is 60 divided by 3. Yes, it can. So this will be 40. 4. Yes, it can. This will be 30. 5. Yes, it can. This will be 120 divided by 5. This will be 24. Let us not go further. Okay, if we can find it in these rows first, then that's awesome. Now this is negative and this is positive, meaning we want a subtraction to be positive. Okay, or in simple terms, we want this to be positive. Okay, like so. Okay, so let's figure out. Okay, now one row will be negative, so that's why I left it out. Now 7, if we see the differences, we are not getting anywhere close to 7. So let's keep going. If we can find a good factor, a good pair. Okay, 5, 6, 7, 8. Does it divide by 8? Yes, it can. Yeah, you might just need to try a lot. Don't worry. Okay, if you are running out of space, then unfortunate, just write it on the bottom of the page with a pencil and go with your day. Now here we see this does add up to positive 7, luckily. So this is our pair, and this is what we need to break it into. So this is 6x squared plus negative 8x plus 15x minus 20x, and 2 is common, so this is 3x minus 4 plus 5, 3x minus 4, and this is 2x plus 5, 3x minus 4, like so. Okay, now just do a lot of them so that you can get the hang of it. Okay, don't worry if you guys don't understand. This is just practice. Practice makes perfect, you know. So 2x plus x minus 15. 2 times negative 15 is negative 30. List down the factors of 30. So this is 130, 2, 15, 1, 2, 3, 10, 3, 4, 5, 6. Okay, now here that's the turning point, so we will just not worry about this. So like 6 and 15 to 18. If it repeats, then just don't repeat. Okay, you can just have one row negative, one row positive, and be with our lives. So one row is negative because to get negative it should be one row at least to be negative. Okay, next we have a positive here. We know that if we add these together we need to get a positive 1. If we add these together we see this equals positive 1. So like that we have a clue as to how should we break this apart. Like so. Remember, I haven't solved these questions. This is at no self glaze. I'm good. Okay, don't worry, you guys can be good also. Okay, 60. Now this is the fun case of both terms will be negative at least. Okay, because to get positive there's only two ways, positive or a negative. But if it's a positive, we can never get a negative number somehow, so it should be the two rows will be negative. Okay, first write the terms, the factors of 60. So this is 2, 30, 3, 24, 15, 5, 60 divided by 5 is equal to 12, 5, 6, 10, and 7, 8, 9, 10. Okay, now after 10 it's the turning point, so we stop right here. As we discussed, both rows will be negative. So it'll be like so. Now if we add these together then we need to get negative 17. So if we look at it carefully, then if we go over this carefully, this gives us negative 17, and so we will choose negative 5, negative 12. So this is x squared minus negative 5x, negative 12x plus 6t, and this is x minus 5 and negative 12x minus 5, and then this is x minus 12x minus 5 and yeah, this is basically. Now this is a fun question. Complete a statement with an expression in terms of m. This cubic, oh no, cubic, we have never learned that in our lives, even if I was forced to. Why is it a cubic? Don't worry. 8m cubed plus 9m squared plus 14m plus 7 is equal to this term and some other term. Now can we have this simplified for us? Yes, we can. Why? If we see, this is a common factor, 9m squared plus 7 plus something 9m squared plus 7. So we can have this. Now if we make pairs, 9m plus 7, this is one pair. Okay, so we need to find some number on the outside, so that will give us the outside. Here we have m common, so we can take m common. Next we have 2 common, 2, and with trial and error, if we expand this back, we indeed do get these two terms. So like so, we find the second thing is 1 plus 2m, like so. No need to worry, this is the same thing as taking common terms, but on a extreme level, such that people who did not look at this video in the past, they may lose. I am skipping this question. Okay, this is like solving. Beyond solving, we are just factorizing. Don't worry. Okay, this is like so many examples. Okay, another example. We can do this. Nope. Dude, there's like no quadratics anywhere. What is this crisis? Yay, finally. And a very tough one. Don't worry, this is not tough. Okay. You need to find two numbers which add up to negative x. Okay, this is negative 132. So we know one row should be negative, and adding a positive and a negative should give us a negative number. Okay. So let's do this. 132. This can be divided by 2. This is 1. No, this is 16. Sorry. You may have a calculator. This is like paper 2 question, paper 2. No, now in the new syllabus, paper 2 is non-calculator for IGCSE. For O levels, it is calculator. So this is like a calculated question. Since it's a old question, paper 2 was calculated also. Okay, 266 and 3. Yes, it can. 1 2 3, which is 44. Can it be divided by 4? Wow, it can. 33. Now let's just keep going. 5 does not work. 6 does work. 22. You need to find if any number works at least. Okay, 9, 10, 12, 11. Ooh, this may give us negative x that we want. Now we have one row negative, and let's test it. Negative 12 plus 11, which is negative 1, and that is the pair. Nice. So this is x squared minus 12x plus 11x minus 132. This is x minus 12 plus 11x minus 12, and x plus 11x minus 12, like so. See, it is easy. Just you got to say focused when doing this. Okay, here's another one. Negative 28. Now this is very easy. Negative 28. One row will be negative because we know that it is, to get a negative, one row should be negative. 128, 2, 14, 3, 4. Yes, 4, 7, 5, 6, 7. That's the tipping point, so we do not write any further. So we save time on our precious 2 hours. Okay, which it's like a generous amount they gave us. Okay, one row negative, and let's see. Negative 4 plus 7 is equal to 3. Wow, instantly. Okay, see, it's that simple. Yes, we may regret saying that later. And you get a ungodly difficult question. Okay, now here we have the x squared having a number to it also. So this is negative 6 that we deal with, and 6. This is 1, 6, 2, 3, and 3 is the tipping point, so we skip it. One row will be negative, and it should give us negative 5. So we see negative 1 plus 6 is equal to 5. So this does not work. And if we do the other row, this will be 1 minus 6 is equal to negative 5. So this does work. Nice. 2x squared minus plus x minus 6x plus 3. 2x plus 1 minus Wow. See, when writing it down, copying it down, you need to be careful that you're copying it down also. If you make a mistake while copying, then are you really copying with focus? Then this is negative 3 2x plus 1. Okay, x minus 3 2x plus 2x plus 1. Okay, remember, examiners may be divorced. Okay, so you need to be careful when working. Okay, I'm not gonna say it. So we have negative 7, and 7 is a prime, so this is the only thing we can get. This is negative, so one row will be negative. So this is negative 1 plus 7 is equal to 6. So we can break it up like so. And we get x plus 7, x minus 1. Yes. X minus 7, x plus 1, and in the denominator we can do that easily like I told you. Okay, I'm going to do this one last thing and then we can end the video here. Okay, I hope you guys liked it, and subscribe, please, share, and bye.